This is lesson 4.2c. We're talking about completely randomized designs. Okay, so and I like the picture of this. I think it's going to make sense, but we're going to assign everything using random assignment here. So we start with experimental units. Those are the people or the animals or the things that we're working with. And we're going to split them by random assignment. We're going to split them into two groups, or this is just a basic, just two groups. Okay, so one group typically is the one that we've randomly chosen, and they're going to get the real drug that we're testing, and the other group will get the placebo. They'll be the control group. We're going to compare them to one another here at the end. So again, treatment one goes to group one. That's probably the real treatment, and then group two gets the fake treatment called the placebo, but it still is a treatment of sorts. Other than that, we're treating them the same. At the end, we're going to compare the results and see which groups did better. Hopefully the one that we gave the real drug to was far better results than the other one. Okay, Harvard researcher was conducting some experiments in Western electrics, Hawthorne works, to see if certain changes in condition would improve worker productivity. One part of the study, a group of workers provided additional lighting, was compared to a group with no additional lighting. So here's the problem with this setup, just the way it's kind of working here, is the workers who got the additional lighting, they know something's going on, right? Their bosses has all this special lighting assigned for them. And so maybe, they did show improvement, but what was the reason? So why isn't it reasonable to conclude the additional lighting is effective in increasing worker productivity? Because it certainly looks like, man, this was done really well. But what's the deal? Well, maybe they knew the results were getting measured. They were part of this study. And the other group was like, I don't even know what's happening here. They didn't know anything. And so this is actually where the phenomenon known as the Hawthorne effect comes into play. So sometimes worker productivity can increase simply because workers know they are being watched and measured. And that's absolutely true. If you're being watched, you're going to probably do a little better job, especially if it's an industry like a manufacturing kind of industry. You're going to be more productive. And so that's called the Hawthorne effect. It probably wasn't due necessarily to the additional lighting, but just the fact that they were being watched more closely by their bosses. They're like, we better turn it up a notch here and work a little harder. Harvard researcher was once conducting an experiment there to see if certain changes, so same situation. So to test the effectiveness of the additional lighting, you recruit 20 similar companies that have agreed to have employees participate in the experiment. Write a few sentences describing a completely randomized design for this experiment. So now I think we have a better shot at doing a good job of working this out. So we had 20 companies. We got a randomly assign maybe 10 of them to get the additional lighting. Maybe 10 of them don't get any lighting at all. The treatment is no lighting. And measure the results at the end. So if you number the companies 1 to 20, use a random number generator like randint on your calculator, or just use a computer or a table of numbers, and produce 10 different random integers from 1 to 20, and increase the lighting at those 10 companies, but leave lighting as it is for the other 10 companies. So I think this is better because now everyone in that same company, the lighting was increased. So I think you don't have, I think it's just a better way to do this and see what happens. And so you're going to measure the outcomes and see if, maybe the additional lighting does make a difference. And so now we have a better designed experiment to do that. That's your lesson for today.